네, 저희 이제 아이온큐 임원분들과 Q&A 시간을 가지려고 합니다. 이제 중간에 계신 분이 이제 피터 제프맨 사장님, 그리고 오른쪽에 계신 분이 토마스 크레이머 CFO시고, 이제 이쪽에 계신 분이 조던 셰프요, 이제 IR 담당자이자 파이낸셜 플래닝 부사장이시고, 이제 여기 다 아시는 김정선 교수님 CTO시자 공동 설립자시고요. 크리스 먼로 교수님은 이제 오늘 다른 일정이 있으셔서 못 오셨다고 합니다. 그래서 오늘 한 4, 50분 정도 사전 그 질문지로 Q&A 세션을 가지도록 하겠습니다. The first question that we have is, will IonQ's QPU networking prototype, which contains the photonic interconnect, would be released to public on this year? If not, when can we expect that to happen?
Yes, so we currently do not have any public timeline for release. These are definitely we're working on these new technologies that will get us to scaling.
Because I'm pretty sure I saw the timeline somewhere on the news, but it wasn't official.
Yes, we were actively working on it
Ah,
right
okay.
now. So very
Okay.
actively working on that particular piece.
And the second question we have is, recently ChatGPT is getting a lot of attentions. So can quantum computer be utilized in this AI field? If yes, how and when do I think that to happen?
Peter, that's your
Yeah, that's fine. So we think so. Of course, you never know until you actually do it.
Yes.
But that's an area we're also investigating right now. We just came out with a paper, our first kind of effort. We started on working on NLP and AGI
Yes.
about a year ago. So a little bit before the Chat GPT kind of craziness. But there's lots of reason. We already knew that that ML was going to be strong on quantum. And of course, if you look at what it is OpenAI has done, it's using large models, large language models. And we think that those will work fairly well on quantum computing. There might be other approaches also besides generative AI to solve this problem. Maybe quantum is actually more natively like the way human brain works. So maybe there's some other solutions to solve that problem.
And I think one of the things, even Sam Altman, he came out and said these ChatGPT type models are extremely resource intensive. Right? It's a huge model, need a lot of data to train, and I think what I read that he indicated that the next generation of ML will have to become more efficient in order to yield more power. So there's a lot of kind of open questions about how both AI and ML will evolve. And I do believe that there's a lot of role that quantum technology can play.
The next question is, the partnership with Hyundai a long-term thing? What is the partnership's ultimate goal for IonQ?
Well, that's a great question. I think Hyundai is a great partner. I think it's a great partner because we understand the opportunity and we understand the risk. So in that sense, I think our partnership has worked out very well. We've been working with them for over a year now. Our collaborations are still very strong. So I think that's going to continue. Of course, Hyundai's interest is whether quantum computing can eventually kind of help their main line of business. And our interest is if we can help them identify that, and then when that happens, we're going to be to help them deploy that. So in that sense, I think our interests are aligned. Exactly how that's going to pan out, I think it depends on how productive we are.
A lot of people actually ask this. So how is it possible to jump from 2024's 35 AQ to 2025's 64 AQ just in a year?
So part of it is we work on multiple generations of hardware at the same time. So it's not like we're starting at the beginning in just 1 year going to make that. The 64 AQ system we've been working on that kind of now for several years. There's multiple machines, each one of them on its own parallel path, pursuing different aspects of that system, which then will all come together in that one system. So it's not just 1 year, it's actually multiple years to build that system.
Well, I understand that in 2025, IonQ will deploy the error correction 16:1.
Yep.
So they will contain more than 1,000 physical qubits, which means you guys will have multiple QPUs.
Well, so This is when you have a roadmap, right? It doesn't mean that I know exactly what to do 5 years from now. It's actually both a goal, and then from that we actually work backwards. What are the technologies we need to start investing today? What are the problems and questions we have to ask and solve today, so that we can actually hit those kind of milestones in the future? So we've actually started out, as Peter mentioned, multiple elements that are needed. Some of them are kind of going to connect so that we can go to multi-modules. Certainly, we have to be ready for increasing the number of qubits dramatically. We focus on error correction. We actually focus on getting better gates. All of these things are elements that we've been working together. And then, as these different fronts evolve, we have a better view of exactly how to actually achieve AQ 64 2 years from now.
And sometimes we work on multiple things that compete with each other because we're not sure exactly which one will win out. So we're working on, if you look on error correction on one side is one way to the answer. The other way would be better gates. So we're pursuing both paths. And so so it's at the end we will choose the best technologies that actually seem to work. So we're often working on solving the same problem with multiple solutions, so that we're kind of de-risking our roadmap going forward.
So how is the current IonQ's QC operation speed compared to the current supercomputers?
Yeah, so the real interesting question is, as the AQs grow, as the quantum computer become more and more powerful, we can actually start to do things that classical computers just cannot do. Right? At that point, the speed for small tasks, yes, we have a very, very powerful computer, but the real value of quantum computer is to be able to do things that classical computers will take ages to complete, right? So I think it's really the scale at which super quantum computers actually outperform classical computers increases very rapidly. So, for example, if we get to AQ 64, we can actually do things that classical computers, even the best supercomputers, will never be able to do, right? So that's kind of the lens by which we have to look at it. And that's why we believe that the first and foremost, we should get to higher AQs so that we can actually outperform any classical computer.
But even in classical computing, you don't see people today competing on kind of clock speeds today. That if you look at the architecture of your laptop, there's a lot of different factors that actually turn out to be the performance of that laptop. We do acknowledge that we want to get our gate speeds to be faster, but we don't think that that's the only answer to this problem.
So the current speed is not where we should be focused on.
It is one component. It's
an important component.
It's an important component. It's just not the only one. So, and especially in these early days, what most people care about is not how quickly you can get to the answer, but can I get the answer?
Okay.
And so, as we get to much larger quantum computers, the gate speed will start to have a larger impact, but it has a smaller impact today.
And it's like when we put the man on the moon, nobody did an expose on fuel efficiency. But fuel efficiency was important because you have to carry all that fuel to get it up there. But there's so many parts of a rocket, and we just want to say, well, can you put the person on the moon or not? And can you solve very complex problems or not? That's the first one. And then how long did it take you to get there? Right.
I'd be willing to wait 2 years to get a cure to cancer.
Right.
It's one of the reasons we've moved to barium, was to improve gate speeds.
So barium QC, well, I'm not sure if I should ask this question. I expect it to be announced pretty soon, so will there be any hints on that?
Well, again, we have not
okay.
decided on the timeline to announce on our barium systems, but we're certainly working on
okay.
multiple fronts.
Okay.
Yeah.
So how long will it take IonQ's QPU to become as small as the classical computer CPU? So original plan, I think, was 2023 to chip size. So what's the current status of this QPU miniaturization?
I actually showed you
Yeah.
the QPU. It is the same size. And if you look
Yeah.
at an Intel CPU,
Mm.
it's actually a little bigger. The size of the overall computer now needs to shrink. So now what our focus is to take the entire computer and start to shrink it to go to rack-mounted, smaller footprints.
And eventually the volume and adoption and industry manufacturing, all of that is going to drive that part of it accelerated very quickly.
If you looked at the lasers that were originally used in Blu-ray players, they were large.
Right.
But it wasn't until we started to put them into commercial electronics that they got smaller and cheaper. So it was the volume, the Blu-ray volume, that allowed that to happen. So we just need to sell as many quantum computers as Blu-ray players, and we'll be able to shrink it down as well. So
That's true for classical computers too, right? The mainframes, they sell very few, it's very large. Whereas iPhones, we sell tens of billions a year, and then they become very small. They shrink down. So there's a direct correlation between volume and size.
So you guys expect quantum computer to be a size of smartphone someday when the market
someday.
grows? Someday,
No,
right?
Probably not next year.
Right.
Microsoft produced a video for the Xbox.
Yeah, I
It was the
actually saw that,
2040,
yeah.
Video, and it showed a little Xbox, and it was supposed to have a QPU. In
Yes,
it,
right.
Like all these technologies, they're all going to shrink.
Yeah, I mean, even these guys,
Yeah,
if
they
you go back, to the 70s and 80s, and say, yeah, you're gonna have this like amazing device that is more powerful than this amazing, the biggest mainframes. Everybody will be carrying into their pockets. I don't think too many people saw that coming.
So when you think about the first computers, they were big. And they're big because you took parts that were used elsewhere and you put them together and you made a computer. And those parts were just big elsewhere. That's what we're doing. We're taking standard parts. They're standard lasers and they're big because in an industrial environment, you don't necessarily care about size. But once you start caring, then it starts happening
Right.
with just more applications and more usage.